Hi, I'm Tammy and I do math for coffee. Today we're going to be writing equations for parallel and perpendicular lines. So you are looking at a graph of a line, y equals 5x minus 5, and we're going to be writing these equations going through the point 1, 3. The y-intercept of the line we're given is negative 5. And so that's this point down here at the point 0, 5. When we write a new equation for another line that goes through 1, 3, it's going to have a different y-intercept. So that minus 5 you're looking at in the equation, that's not part of the process. And you'll see what I do with that when we start working the problem, which we're about to do right now. Write the slope-intercept form of the line that goes through the point 1, 3 and is parallel to y equals 5x minus 5. We know that the slope of the line that we're given is 5. If you remember, y equals mx plus b, m is going to be the slope. What I just mentioned is that the negative 5 in this equation is not going to be part of our answer, so I'm going to cross that off. We know the slope of our new line has to be 5 because we want a line that's parallel, and parallel means they have the same slope. We want to go through the point 1, 3. The x value for the point will be 1, and the y value for the point will be 3. Start with y equals mx plus b as a general template for how to set this up. We know all of the variables except for the new y-intercept, which is b. We know that the y is 3, slope is 5, we know that the x is 1. And then you just put plus b, and that's what we're going to solve for. 3 equals 5 plus b, because 5 times 1 is 5. Subtract 5 from both sides, b equals negative 2. So we know that we can put the negative 2 in for b. Now when we go back to write the equation, the parallel equation is going to have the same slope. So it's y equals 5x minus 2. Now that's how you're going to do it on paper. Your teacher's probably not going to let you do it using a computer program, but I'm going to use a computer program right now to show you that that is the correct answer, or we're going to find out I did it wrong. Well, that's what we got, 5x minus 2. All right, let's do the same thing, except now we're going to be doing it with a perpendicular line. The process is the same, it's just that you make a little change with what you do with the slope if the line is perpendicular. Our perpendicular slope is going to be negative 1/5. You use the reciprocal and you change the sign. If it's perpendicular, it's got to make a 90-degree angle with the given line. So if one line's moving up, the other one needs to be moving down. It needs to be opposite. We still need to go through the point 1, 3, and we still know what the x and the y are. Setting up our y equals mx plus b and popping in the numbers that we know. And now we're going to solve for b. This one's going to be a little trickier because there is a fraction involved. And I have to warn you, if you're doing parallel and perpendicular, one of them will be nice and one of them is going to have a fraction, usually. So in this one, we want to add 1/5 to both sides. 3 1/5 equals b. Usually in algebra, we're not going to use mixed numbers and we'll change that to an improper fraction. So 3 times 5 is 15 plus 1, that is 16/5. So our perpendicular equation is going to have y equals the negative 1/5 has to be the slope of the perpendicular, and our y-intercept is 16/5. Okay, now let's head back into the computer, see what that's going to look like. I select the line that I was given, which is the 5x minus 5, and I select the point that I want my new line to go through, and I tell it I want it to be perpendicular. But the computer program is going to give me the equation in decimals, so let's check and see if the decimals work out to be the same thing that I got as fractions. I have a slope of negative 1/5. 1 divided by 5 is 0.2, and sure enough, we have a negative 0.2 slope. Y-intercept is 16/5. Let's do that. 16 divided by 5, and we get 3.2. And even if you look at the graph, you can see that the y-intercept point on the purple line is just a little bit above the 3. Now the last thing to check is this a perpendicular line? It will be perpendicular if it forms a 90-degree angle, and I can have the computer measure that for me. I select 3 points that make up the angle, it does the measurement, and boom, sure enough, there it is. Hey, if you are in algebra, click into this playlist next. Thank you, bye!